Well, good morning, everyone. Hope you had a great first session. Yeah, it's super cold up here. Is it cold in Houston as well? All right. Well, we've got a few people here. I was curious if how much interest there would be on JUnit testing, but I'm glad to see a few folks are interested. Is the audio working? The last session I had, the audio wasn't working well. Could somebody just throw me in the chat if you can hear me? Yes. All right. Perfect. Thank you. All right. Well, let's Um, so the kind of the driver behind this presentation is that just doing programming assignments in a pandemic is really, really difficult. And so I'm sure, like most of you, I've been playing around and trying to find some things that work for my programming classes. So I teach mostly, all high school programming classes, and so trying to find things that work, especially for the AP Computer Science A class, because they're doing labs is a really important part of that, and finding a way to give feedback that's useful is really good. So a lot of the year, my classroom kind of looked like the one there on the left. It's just been empty. We've all been at home, and we've been doing things remotely. And so then I'm sure my students have felt like this person here on the right. It can be frustrating when you're learning how to program on your own and there isn't a whole lot of feedback. And so trying to find a way to make that work has been a little bit difficult. And then the past couple of weeks I've been on quarantine, so my students have actually been at school, but I've been at home, and trying to figure out how to make that work has been tough. And so here's some examples of some labs that I really just don't care anything about grading. So like sometimes the one over here, the output is just wrong, and the student obviously, whatever, they didn't give the right output. And then sometimes I even get labs that don't compile, and so that's kind of frustrating because that's kind of it's kind of a waste of my time, and it's a waste of the students' time for me to look through labs that don't compile. And then sometimes you just have students who want to make sure they get something turned in on time. I had this happen this year where I actually got an IDK in a comment, and so that's a little bit frustrating too, because time's limited. And so looking for something that can help avoid these situations, doing some unit testing, actually letting the students do the unit testing can be a real lifesaver. And so we use JGrasp in all my classes, but what I'm going to show you will work with Repl.it or GitHub Classroom or whatever tool you use. Most of the tools will let you do some kind of unit testing. And so if your students are already using JGrasp, it's easy for them as clicking this little button up here at the end to open up a test file. And so then I provide the students this code, and so it just tests their program. And so for that example, where all they had to do was to print 3, so it's really as easy as just a few lines to see if their program prints 3. And if it does, they get this nice green bar that says, yes, you pass all the tests. And if it doesn't, they get this red bar that says which tests that they failed. And depending on how detailed of an error message you want to get, you can tell them, you can give them some clues on why their code didn't work. And so the reason that I like this is because it gives the student the responsibility of running the tests and seeing if their code works. And so the code that they give me is always going to compile, and it's always going to give the correct results. But then I can check for other things like style conventions or whatever. And also this is really nice for students because if their code doesn't work, they know right away. Not only that it doesn't work, but they have a pretty good clue once they run the test on why it doesn't work. And so this is as good as I can find of really fast feedback for them. And so it cuts down on the frustration for the students as well. And so then the way I do this in my class is I just have them paste some output from the test file. They just paste that in theirs. And so then when they turn it in, I can see that it's already passed the test. And so this kind of shifts a little bit of the responsibility that I was taking before and gives that back to the student. So the student, before they turn anything in, they're making sure that their code compiles and that it gives the right values and that it has the right class names and method names, those sorts of things. And then I'm really just checking to make sure that their code meets the expectations for style or whatever expectations you have for those. And so my goal for today is to show you how to write some of these basic tests. And hopefully, if you'd like, you can follow along and write some of those tests with us. And so all of the code is right here on this GitHub link. And so you can get that. And if you've already used JGrasp, that's great. Or if you want to download it, it's a fast download just at JGrasp.org. And so you'll be able to play along with us. Or if you've already used some unit testing and you want to use it on whatever platform you use, that would be fine too. So I guess what I'd like to do is just pause for a minute, let anybody who wants to grab that code, and then if anybody would like to jump in and just tell me what platform you're using for your labs already and what experience you have with doing unit testing, that would be awesome too. Yeah, that's a great idea. Thank you, Sylvia. Let's see. Yeah, that's a great point, Ron, because especially as the labs get a little bit more complex, we can have some simple test cases for the first part. And so then the students can make sure that part's working before they use anything else that depends on it. Okay, also, with PyTest, cool. So are your students programming in Python then, or are you? Okay, neat. Okay, awesome. So Harlan, does IntelliJ have the unit testing built in, kind of like JGrasp does, where it makes it easy for the students? Yeah, very cool. Gotcha. Are you using the unit test in your class then? Okay. Neat. Yeah, I'm not sure if BlueJ does the unit testing, but okay, good. I'm not sure how the unit testing works with BlueJ, but even if it's not built in, it would be easy enough to do outside of BlueJ. And I use Canvas. I use Canvas as well, and so let's see. It's JGrasp like this, and so their website is jgrasp.org. And so that IDE comes from Auburn, and it was really meant for teaching computer science. And it's got a great visual debugger in it, and it doesn't have all the fancy code completion stuff that something like IntelliJ or Eclipse does. But I found that that's really good for learning to program, for teaching programming works well. Well, hopefully everybody who's wanted to's had a chance to grab that code. And I'm going to show you what it would look like to write a code for a lab. Yeah, for first-time programmers, it's great for sure. All right. So here, this is the JGrasp IDE, and so I've got just some very simple sort of something that might look like a lab. So it's got some custom methods, and it does some things like that. And so I'm going to show you what it would look like to write some test files for this lab here. So to get started, I'm just going to click on the JUnit test file button there, and it's going to pop up this really simple test file, and you can see that it fails by default. And so that's kind of a good way to make sure, or to see that we've got the default test file. And if I run it, I can just hit the little running person here with the unit test, and it's gonna. I hope that's big enough you can see. But it's got the big red bar. It's pretty easy to see that it failed, and it even gives me a message: the default test that was added by JGrasp failed. So I'm going to delete it, and once I've added my own. And so I always start like that, and then I've got a template file that's in that Git repository. And so I'm just going to come over here and select all of it, and then go back to that default test that it opened and paste it in. And so now I've got some custom methods that I've written that make it a little that make the test work a little bit better for me. And so I'm just going to make sure all the naming is right. So by default, when you write a test file, it's going to be whatever the name of your .java file was. So mine is just lab now, and it's going to put test on the end. So this should be lab test instead of template test. And so we can just do a quick find replace. And so I've got template, and I'm going to replace that with lab for today, and just replace all. And so now I'm good to go, and this test file should run. And here, just to make sure that it does. Yeah, my default test failed because that's what I told it to do by default. And so now really the only things I'm going to change are right here in this section with my test files. And so writing the test files is pretty simple. Let's go back and look and see it's something that I could test in my lab file. So it's supposed to print out hello world. And so since I've already got the solution and I know what it's supposed to print, I can just go back to my test file, and I've got a method called run main. And so run main is just going to send any input that I give to it, and then it's going to tell me what the output, from standard out was from main. And so if I want to make that work, and I've also got in my test snippets file over here, I've got this one. So test main, and you know what? It might actually, I'm just going to copy paste that whole test and replace my default test with that one. And so I wanted it to say hello world. And so then I'm going to, let's see. And so this is going to run the main method, get the output, and then it's asserting true. So it's saying that this condition should be true. The output that I got when I ran it should be hello world. And if it's not, it's going to print that message. All right, so I'm going to compile and run my test file. Oh no, it didn't pass. I must have mistyped something. Let's see. Oh, it looks like I used a lowercase w. All right, so cool. And so now I've got the green bar. And so for a student, this can be really nice. We've just done one part of a simple lab, but already we've got the green box. So that lets a student know that what they're doing is right. And especially as we have students that are at home, maybe they're doing this on their own. That can be really that can be a good thing to get a little boost of confidence before they go on with the rest of their lab. How do you test when there is no printed output? So like, would that be for using a custom method maybe that's going to return a value? Is that kind of the use case you're thinking about, William? And I'm not sure if this is what William was. Okay, array modification, sure. So for unit testing, unit testing really doesn't care much about the implementation details. And so unit testing wasn't really made for grading labs, right? It was made for testing small components of a program to make sure that they work. So we can build from the ground up to make sure that our whole program is working well. And since the unit testing doesn't really care about the implementation details, it's pretty tough to check the value of one variable or something like that. So this is really only going to be good if you're looking for output, or if you've got a method that you can check, something like that. And so I generally do methods pretty early in the year, in large part just so I can use unit testing. But let's do something that might get a little bit closer to that. So if I go back to my lab file. Yeah. Here's one that we've got a custom method that we can test. So this method just takes two integers and looks to get the maximum out of that one. And so let's see, I'm going to go to my snippets file, and yeah, so this looks like it's just a basic method sort of thing. So I'm going to use that snippet and put that test in. All right, and so here my method name is getMax, and it takes two things. And so the maximum between 1 and 3 should be 3. All right. And so I guess this would be a good time to show kind of some of the setup. So this method here, because it has the before keyword, is going to run before every single test. So every method that has this test identifier, before it runs, the before method is going to run, and then after it, the after method is going to run. And so in my template, all I'm doing is setting the output stream so that if there is output, I can get it, and then tearing that down afterwards. But I'm going to, part of the before method is going to make a new lab object, or whatever you named your lab. And so then any method that I want to run, I can access it just by using tester dot. So tester dot get max 1 3, and so it says that should return 3. And then we've got this error message here, and so you can kind of decide how much feedback you want to use. So a lot of times I will give the inputs and the outputs and tell the student what I expected to get. And so let's see if this runs. We're not going to see anything here because it passed. So it's not even going to tell them. It's not going to give them any of these details unless it fails. And just to see what it would look like if it failed, let's say that I just switched that up. All right, and then recompile it. And so then I run my test files, and then I'm going to see that error message that we printed. So get max 1 3 doesn't return 3. And so this takes a couple of days of training with the students for them to look in the right place and see what the error message is, and so they can go on from there. Let's check the chat real fast. Oh, gotcha. So back there in that last one that we did, William, I got the half red, half green because it only passed one of the tests. So that the Hello World test that we did first, that one passed. So we got the green bar for that, and then we got the red one. And so if you have a whole lot of tests, it's kind of neat for the student because they start off with a big red bar, but then as they implement different sections and get different parts, they're going to go from all red to all green as they go. Harlan, that is a great question. I just kind of got in the habit early on of using assert true, and I have no good reason for it at all, other than that's what I started using. Do you have a preference? Do you? And there's a lot of other assert methods that you can use as well. So there's an assert that kind of works like an assert true. There's also an assert false that you can use. And I just kind of got in the habit of using assert true. Yeah, so I don't have any other reason. So it doesn't really matter as long as this part in the end is going to give you a Boolean. So as long as this part here gives you a true or false once it evaluates, this way always works. So yeah, and that's a great point too, Harlan, about floats. Because I know I just used one of these where we were finding the average of an array, and So one of the things I always work towards in the second semester of my AP class is that I eventually get students writing their own test files for the labs. And so some of my students, of course, it kind of makes sense that if we're doing the average of an array, they think, oh, well, the average should say equal to. And so they'll say get average equals 2. And that may work in some situations, but since you're using floating point arithmetic, of course, if there's some situations where because of round off or whatever, it's not going to be exactly equal. And so we had them just use the absolute value and say it's less than some, like you would check for floats. So that's another good question. How many tests do I use? I try and do enough tests so that the student can get a little bit of success. So some simple tests that they can get and make sure that what they've got is working. Since you can't really test for the implementation details, you can't do any more tests than you've got separate methods for, really, I guess. And then maybe a couple of edge cases that we might check. Yeah, let's look at one of those edge cases for a test that we might write. So yeah, here I've got the maximum of an array. So the question for the student would be, given this array of integers, go through and find the maximum and return it. So let's look at what kind of tests we would write for that. So in my snippets file, I think I've got one that already has an array in it. Yeah, so I'm just going to take this one and paste it in here. All right, and so I think the one we said was get max, and so if 1, 2, 3, that should be 3. Awesome. All right, and so we can send, since our lab has, it takes in an integer parameter. It looks a little bit weird to put that in as a parameter for the method, but it works like that. We can just make a new integer array and send it. And so let's make sure that compiles and works. Awesome. All right. So here I'm thinking of an edge case that I would probably want the student to check for. Since we didn't make a precondition that the array was non-empty, we might want to check, write a test for that. And so here I'm just going to copy and paste and send an empty array. And if we send an empty array, then we actually want an exception. And I don't think I put a snippet in my test file to check for that it throws an exception. So I'll put that in a little bit. But that's a pretty easy test to run too, to say that when we run this, it ought to throw an exception. All right. I really wish I put that in there. Sorry about that. So for now, let's just say it was supposed to be positive integers and it was supposed to return -1 or something like that. And so, of course, if I run it, it's not going to work because I got the index out of bounds exception there. And so then the student will be able to see, oh, something weird is happening there because the test has a length of 0. All right, so I'll make sure I get that added to the snippets in the GitHub test to check to make sure that an exception is thrown. Of course, that's probably, I probably wouldn't even have that for an APCS A class anyway, since exceptions aren't tested, but that would be an option. So in practice, I'm lazy, Harlan, and so I generally put, I will test a lot of things in the same method. That's a good point. So in this situation, this is not how I would have written it for a class. I would have just put it right there, and done that all in one method. And it's still going to look the same for the student. So they're still going to see that they're still going to see the same thing. When at least in JGrasp, it's still going to show that they failed that one. So I would say that's kind of a matter of preference. So however you want to do that. We can also test void methods and that where we're expecting output. So here, print hello, send a name. It should be hello in that name. So I'm just going to copy this. I'll drop it in my test and then come get from the template one that we're going to do that. Oh, and snippets. So using standard in and standard out is a little bit tricky using the test files. But so that's why I always just keep it here in my snippet file so it's easy to use. And so let's paste it in so we can see what it's going to look like. So when we have a void method and we're testing for output, we have to take care of changing the input and the output streams. So here, this string, here, I'm going to take that out since we don't have any input. So we're just setting the output stream, and then we can run it. And so I think mine was, I don't remember what the name was, called it print hello. And so then we will put there and print a name. All right. And let's see. Yeah, I need to fix this in the snippet. I haven't used it in a while. So it should just be public void. And then instead of returning the string, we're going to actually do the tester here. So we can assert true that we got hello name. You know what? I haven't used this one in long enough that it just doesn't work. I need to update that one. Yeah, I'll take care of that. Sorry about that. All right. But that's a pretty easy test to do as well. And then here's a string method. So this zip string method, it's supposed to take two strings and just zip them together. So it's just going to put them together. And so we can do an easy test for this one. This would just be another method test. So I've already got that one. We'll use it. One thing we do have to look out for is to make sure that with all the copy and paste that our method names are actually different. And so I normally just throw a number on it or something like that. Let's see, zip string. And we can put two strings in here. So do ABC, EFG. And if that works, it should give me A, E, B, F, C, G. And I can't use equals because we're doing a string. And so for strings tests, I almost always use contains because just in case the white space is different or something like that, that can be really frustrating for a student if you've used dot equals, but then they're off by white space on the beginning or the end, unless that's what you're testing for, of course. But most of the time, that's unimportant. You just want to make sure that they get the results right. And let's see if that test worked with contains. No, it didn't. And this time I didn't get a message either because I didn't program the message in. And so for students, most of the time we want a message in. And so we can, here, that's the output that we're looking for. And so since that returns a string, let's see, we can just do output should be oh, And it looks like when I wrote this, okay, so it looks like I just did my sample lab wrong. But anyway, that would work. And so this is going to be something you kind of have to decide as you're writing the test. How much output do you want? How much output do you want to give the student? Do you want to tell them exactly what it should be or what you're testing? And I found most of the time, in a contest, if you're writing the test cases, you might want to be kind of tricky and elusive about what you're testing for. But when you're doing this for a classroom and you've got a student that's working at home on their own, you probably want to give them quite a bit of feedback so that they're not having to guess. And so generally generally I default to giving quite a bit of feedback when I'm doing something like that. And again, I think the goal for this is always to get students to the point, especially your more advanced students in an AP class. They should be writing their own test by the end of the year. And this year I've got a couple students that are just a little, they're more advanced than other students in the class. And so they're actually going a unit ahead and writing the test files for the other students. And then, of course, I'm, testing their tests before I give those out to the students. But that's worked. That's worked really well, and kind of giving them a little bit more ownership of what they're doing too. Yeah, it definitely can be like pulling teeth. That's about what it's like sometimes. So this year I've just got students who actually they kind of enjoy doing that, and they're taking quite a bit of pride in it. It doesn't always happen like that, but I enjoy when it does. I've also given some test files that don't work to advanced students who they like problem solving. And so I've written some test files that don't work, or written a lab that doesn't work, or given them a little something to get started on. Yeah. Let's see. Trying to think. I mean, those are the big tests. Does anybody have any ideas of something that you wanted to test in a class that maybe we could go for? Or all right. Well, yeah. So the time I spend writing tests. So this is probably backwards. I know in industry the goal is to always write the test first, and then write solutions. But generally, when I write a new lab, I will write the solutions first, and then I write the test. And most of the time, I've kind of got the snippets down, and with copy and paste, that doesn't take very long to write the test anymore. And then I just put all of those in one big zip file and send those to students so they get the zip file that has that has a, let's see, here I can show you kind of what I would give to the students then. Let's see. So I've got one folder that I keep for myself that has all of my solutions and all of my test files. And then it's probably not the best way to do it, but I have a separate folder of just the student files. So let's see, here's one that we did recently. And so I would give this to the student. So I've got some, we're just doing arrays now. So I've got some sample arrays there. And then in the comments, I just give them the instructions for what I want them to do. And so I would start by writing this file, and then write the solutions in and write my test. And then I would give them this in the test. Yeah, I know. I'm sure that anyone in industry would say I'm doing that all wrong, but kind of one of those situations where I don't care if it's wrong. It's what works. So. Cool. Well, it's kind of a fun way to be able to give students a little bit more faster feedback than we could if we were just having them turn labs in. And so if this is ever something you want to try out, my email address is on, actually, I don't think it's on the first slide, but I'll put it there. And so if you ever get stuck writing a test or whatever, it's kind of fun debugging those. I'd love to help out. Oh, that is a great question, Harlan. Yeah, that happens. That happens fairly regularly, because what I found is once the student is taking care of this, I can focus on the things that I care about, but I haven't been able to care about in the past. Things like one-letter variable names all the way through their code, or using the variable name poo all the way through. That seems to happen pretty regularly. And so I do my labs on either, so the only 2 grades I give to my labs are it meets the requirements, or it doesn't meet the requirements yet. And I let students resubmit those labs over and over and over again until they get it right. And so if I get a source code file that is full of poo, I will definitely say it does not meet requirements, even though it passed all the tests, and send it right back to them, and then let them fix it and they resubmit it. And so that definitely happens sometimes. Also, another thing that can happen is I'm kind of a stickler in the AP class for when we're doing labs. We actually use the AP subset. And so I've always got a couple of advanced students who maybe they use .contains as a string method, and I want them to actually write a for loop and search a string. Kind of want them to do it the hard way, just so they get into practice. And so I'll send that back to them, and they can, they can modify that and resubmit it. It seems like there was something else I was thinking about when you mentioned that, but my brain is a little bit fuzzy. Not sure. No. I've also found that kind of takes a little bit of the pressure off of the labs too. Before using the test cases, sometimes it took me a little bit longer to grade the test, or to grade the labs. And so, it might be a few days or even a week before a student got feedback back. And so by then it was kind of like, we'd already moved on, and it was tough. But now I'm able to grade the labs a lot faster, that I'm not having to check for correctness. I'm just looking for those style things. And so it's a lot easier to use that model of having them resubmit until they get it. And I've also, anytime you do, or at least I found students will find a way to cheat on things, kind of no matter what we do. But starting this year, I've had them take this output from the test file and just copy that to the bottom of their lab. And so I can kind of do quick checks, and like after I've graded a few labs, I know exactly how many tests it has. And so if they copied this from a different lab, it might be more obvious, or if the date was, if the date was crazy or something like that, that might be something I would notice. But mainly it's just so that I can look really quickly and make sure the students actually ran the test files. And that's an automatic. I don't even look at it if at a lab if they don't have that output there. And so that took a week or two to get students in the habit of always putting that test output there. But now it's just part of the routine now. So cool. Well, thank you everyone for coming, and I hope there was something that was useful there. And let's see, I'm going to put my email address down here. And so if you ever want to talk test files, I'm always just an email away. No, so JUnit is it's a Java thing, and it will work pretty much with whatever platform you're using. So Harlan was saying it works with IntelliJ. It's already built in. I've used this with Repl.it before, and so there you just write the test files inside the browser, and it runs them automatically anytime a student submits a code. But it also works with GitHub Desktop, or I'm sorry, with GitHub Classroom. Works pretty seamlessly with those. Yeah, you may need to do an import with Eclipse. I was really surprised at how easy it was with JGrasp, because JUnit isn't part. It's not part of the JDK, but it's bundled with JGrasp so that it works automatically. Depending on what you're using, you may have to import a jar file or something like that. And of course, if you're using something besides Java, there's libraries for Python and C++ as well, where you can do the same thing pretty easily. The code may look a little different, but the idea of unit testing works really well in the classroom. Yeah, for sure. Cool. All right. Well, that's all that I have. Thank you, folks, so much for coming, and I hope something is useful, and hope you enjoy the rest of the sessions today. See ya.